In this example, we're going to see how to apply L'Hopital's rule to indeterminate forms that involve exponentiation. So the three indeterminate forms we're going to look at are 1 to the infinity, 0 to the 0, and infinity to the 0. And essentially all three of these forms follow the same procedure. So suppose you want to compute a limit that looks like the limit as x goes to a of some function f of x raised to some other function g of x. So the first thing you want to do is check that the limit is one of the forms, so one of these three forms. Then take the natural log of the whole thing, which will allow you to rewrite the limit to look like something like this, so in fractional form. And then this new limit should be one of the forms 0 over 0 or infinity over infinity, which is what we want, so that we can apply L'Hopital's. And then we apply L'Hopital's to compute this limit. But then, because we took the natural log in the first step, we need to undo this, and so we exponentiate the result to get the actual answer. So let's try to follow this procedure in an example. Okay, so this is our example. So let's scroll down. Okay, so we want to compute the limit as x approaches 0 from the right of 1 plus 4x, the whole thing raised to the 3 over x power. Okay, so first we check what happens when x goes to 0. So as x goes to 0 from the right, 4x, so it's just 4 times 0, goes to 0, and 3 over x. So here x is getting smaller, so if you divide by a small number, the number gets bigger. So this goes to positive infinity. And so 1 plus 4x to the 3 over x. So this goes to 0, so inside the parentheses it goes to 1. And then 3 over x we saw goes to infinity. And so this is of the form 1 to the infinity, which is exactly this form here. So we can apply this procedure. Okay, so now that we check that it's one of the indeterminate forms that we want, so we take the natural log. So this was the first step. Second step, so then the limit becomes the limit as x goes to 0 from the right. So taking the natural log of this, the exponential will come down in front. So 3 over x times, so that's from the rule of logarithms, times the natural log of 1 plus 4x, which can be written as the limit as x goes to 0 from the right, 3 times the natural log of 1 plus 4x over x. So now x goes to 0, this part goes to 0, the natural log of 1 is 0, so the numerator is 0, and the denominator is also 0, so this is of the form 0 over 0. So we can apply L'Hopital's rule. So this becomes the limit as x goes to 0. So taking the derivative of the numerator, so we have to apply the chain rule. So the derivative of the natural log is 1 over, so the 1 plus 4x goes in the denominator. It times the derivative of the inside, the derivative of 1 plus 4x is 4. And then the derivative of the denominator, derivative of x is 1. So this is applying L'Hopital's rule. And then we can rewrite this as the limit as x goes to 0 from the right. So 3 times 4 is 12. and then this part can bump down to the denominator. So 1 plus 4x. So now we can just evaluate this limit. So plugging in 0, you get 12 over 1, which is 12. So this limit is equal to 12. But again, because we took the natural log in the beginning, that changes the function. So we have to undo it to get the original answer. So exponentiate to the answer would be e to the 12th power.